Hi and Assalamualaikum. My name is Ahmad Fikri bin Sarimi. So for today, I would like to present my final year project 1 presentation. The title of my final year project is to design a kitting rack for Volvo rear back plastic parts in Indian automotive settings, Sdn Bhd. So my supervisor is Dr. NURSALBIAH binti NASIR and my co-supervisor is NURUL ATIKAH binti AZIS, which is the engineer in Indian automotive setting. For the abstract of this final year project is to design a kitting rack for rear back plastic parts for the Volvo production line in Indian automotive settings in Sdn Bhd. Focusly, the kitting rack will be used at the rear back assembly section line. Other than that, the abstract for this final year project, a final detailed drawing will be made and a prototype will be fabricated so that the kitting rack can be used at the rear back assembly line. Kitting is the process of collecting the parts and components used in the manufacturing process of the product and delivering the parts to the point of use of the line side of the kit. Kitting is used to improve the working efficiency for the operator at the production line. The kitting kit will be designed in a form of a slotted rack where all of the plastic parts can be arranged inside it. Several past studies have been identified as per my literature review. First, we have the kitting and time efficiency in manual assembly. The summary for this literature review is the research will be focused on part presentation in manual assembly and also explain about how kitting affects the time spent by the assembler or worker fetching the parts and what is the impact of the proportion of part included in the kit. The relation of these studies with my project is to determine whether the kitting method can reduce the time for the assembler or operator to assemble the plastic parts. Next, we have an evaluation of kitting system in lean production. The summary of these studies, it will explain that kitting activities are used to solve several issues such as lack of space, quality, flexibility, material handling, and learning. The relation of these studies with my project is to identify past research about why it used the kitting method and what are the problems faced by them. Next is the kitting versus line stocking, a conceptual framework and a descriptive model. This past research will explain about to present fundamental differences between kitting and line stocking and study most of the kitting operation. The relationship of this past study with my project is to identify more about how the kitting operation work in terms of material handling and space requirement if the kitting principle is being implemented. Then we have the improvement in material feeding system through introducing kitting concept in lean environment of MSME. This past studies is made in the manufacturing company. So the past studies will tell about it will be focused on the material feeding principle of kitting within in-plant material supply in mass customized assembly. To relate the past studies with my project is to know about what improvement can be done if choosing the kitting method in a lean environment. A case study of a principally new way of material kitting and evaluation of time consumption and physical workload. Basically, these past studies explain about the material kitting should improve the productivity as compared with other kitting method and has a potential for further improvement. So, to relate with my project, it is used to study about whether the kitting principle can reduce working time and relate it with the same situation at the Volvo production line, where it used the material to picker method. Then we have the application of lean line feeding for increasing productivity. So for these past studies, it presents how the application of lean logistic principle to the line feeding of an assembly line contribute to the increase of productivity in a new truck plant in Brazil. So, to relate with the study that kitting implementation improve the productivity of the manufacturing. Next is the man-hour efficiency of manual kit preparation in the material supply to mass customized assembly. This past research explained about the purpose of exploring how the man-hour efficiency of kit preparation is affected by the design and the context of the kit preparation. To relate the past research with my project is to relate with the study about the effectiveness of kitting method with the production productivity. Problem statement. The problem statement for this project is insufficient parts supply to the rear back assembly section, and also unsystematic rear back plastic parts arrangement at the assembly line. The objectives of this project is to develop detailed design of the kitting rack for the Volvo rear back plastic parts in CATIA software. Next is to fabricate the prototype of the kitting rack. Third is to analyze the performance of worker efficiency based on the usage of kitting rack at the rear back assembly section by using time study method. For the scope and limitation of project, first is to gather all information about the rear back plastic parts in terms of its name, part number, its dimension, and also its variant. Next is to perform the kitting trolley conceptual design on CATIA software to visualize the idea of the rack. Next is to perform time study to analyze the effectiveness of using the new rack at the Volvo assembly section line. So, as we can see on the slide, it shows the flowchart of the methodology for this project. It starts with the problem identification, gathering information, sketch conceptual design of the kitting rack, product design specification, develop the CAD model, finalize the design product, discuss the price of the rack with the supplier, then procurement and fabrication, and finally testing of the product. Methodology explanation. First, we got the problem identification, where all of the problems are based on the observation and data gained at the Volvo assembly line. Next, we have the gathering information, where a case study about the rear back plastic parts is made, and also a study about the existing kitting rack at Aden. Next, we have the sketch conceptual design, where several ideas are being sketched based on the current situation at the assembly line. Next, we have the product design specification, where I will decide the dimension of the rack and the material of the kitting rack. So we have the developed CAD model, where the design product is being designed in CATIA. Next, we have the finalized design product, where I will present the ideas of the kitting rack to the engineers, whether she accept or not the ideas. Next, we have the testing of the product, where I will make a time study to analyze the workers' efficiency using the new rack. As you can see in the slide, it shows the case study for the rear back plastic parts, where I tabulate all the data of the rear back plastic parts for every car model, such as Volvo XC60, XC90, XC40 in a table, and I list out all of the dimensions so that I can determine the largest dimension of the plastic parts in order to design the slotted space on the kitting rack. As we can see on the slide, it shows several pictures of rear back plastic parts. All of the parts will be arranged inside the new kitting rack. For the morphological chart, there will be 3 design concepts that will be made by me. All of the 3 design concept has different sub-function for every of the design. This is the pure chart of this project. As we can see, there will be 3 design that will be compared with the datum. As we can see on the slide, the highest net score by the design is design 3. This is because design 3 has the best criteria of all the design. This is the expected result for this project. First is a final conceptual design of the kitting rack. Next, the final conceptual design will be divided into 2 racks, which is the 60% and 40% side of the rear back plastic parts. The kitting rack is designed with several slotted space on it. Each of the slotted space is reserved for each type of the plastic parts. This is the final conceptual design for this project. Basically, it will have 2 rack, which is the 60% kitting rack and 40% kitting rack, as the rear back seat will be divided into 2 parts, which is the 60% and 40%. So all of the side will have their own plastic parts. This is the labeling of the plastic parts for the 60% kitting rack. As we can see, every slotted space is being labeled with their own types of plastic parts. This is the labeling of the plastic parts for the 40% kitting rack. All of the plastic parts are being labeled with different colors so that the workers at the assembly session can know the place of the plastic parts. This is the product design specification for the kitting rack. First, we have the material of the kitting rack frame, which is it is made of mild steel. The selection of the material is discussed with the Co-Supervisor. Next, we have the dimension for the 60% kitting rack and also the dimension for the 40% kitting rack. Basically, the size of the 60% kitting rack is much larger than the 40%, as it have many parts compared to 40%. Other than that, the dimension of the kitting rack is based on the safety guideline prepared by the safety officer in ADN. Next, we have the safety features, which is the forklift slot and wheel barrier. The wheel barrier is made to protect the wheel from the forklift blade. As we can see on the slide, it shows the project planning for this final year project 1. For the conclusion of this project, a suitable material and dimension have been successfully identified for the kitting rack. Next, the idea of the conceptual design of the kitting rack is chosen based on the highest score obtained from the pure chart. Next, the final conceptual design is more ergonomic and user-friendly for the workers at the assembly session. Finally, the slotted space is designed based on the largest dimension of the plastic type. And this is the references used for the literature review for this project. And that's all from me, and thank you for lending your ears to hear my presentation. Thank you.